Hello students, welcome to our new video. So in today's video we are going to learn in details about stacks and subroutines. So let's begin with what is a stack. I think all of you know a stack is a set of memory locations. It is located in the memory and it operates in the manner of last in first out. Okay, it works in the manner of last in and first out. So if you store 1, 2, 3, 4 in the stack, and if you want to retrieve back from the stack, you will be retrieving in the in this manner 4, 3, 2 and 1. Okay. Now, next for example, your message folder, your email folder, okay, all of this works in this method, last in first out. Okay. Now suppose this is your memory. This is your memory. This is the stack. Okay, this is the stack pointer. Okay, the top of the stack is the top of the stack is called by stack pointer. Okay, now address of the stack of this stack of the top of the stack is given by the stack pointer. Now what is stack pointer? Stack pointer is the address of the top of the stack. Understood? Stack pointer is the address of the top of the stack. This is your top of the stack. So stack pointer is the address of the top of the stack. Clear? And these are the various elements of the stack. Okay. So let's get clear. Let's revise it again. What is stack? Stack is a set of memory locations. Okay, fine. Now next it is present in the memory. Second, third, a stack pointer is a register present in MUP. Okay, it contains the address of the top of the stack. Understood? Stack pointer is present in the MUP, but it contains the address of the top of the stack. So why are we interested in the top of the stack only? Can you tell? Because when you do a push and a pop, I think you remember a push and a pop. Okay, what happens? What happens? Both can happen at the top of the stack. When you do push and pop, this two operations operates on the top of the stack. Okay, so you push a new element, it will come at the top of the stack. You pop an element from the top of the stack. Of all the elements present in the stack, the one that will participate in push and pop is the top of the stack. Understood? I think it is understood. Hence, stack pointer contains the address of the address of the top of the stack. Okay, so these are all the basics of stack. I hope it is clear. I think you have learned it before also in your theory classes, as well as I have told you something during the instructions. Still, I am repeating. Okay. Okay. Now let's discuss about the uses of stack. Now the first use of stack is to store data. Okay. The most important use. Okay. All of you know the most important use of stack is to store data. Now tell me, where do you store data? We store data in registers, right? Now, what happens when you don't have an unlimited number of registers? You have only 7 registers, right? A, B, C, D, E, H and L. You have only 7 registers. Okay, you don't have unlimited number of registers. So if you just keep storing data in registers, do you understand after a point all registers will be full? Are you getting my point? If you if you start pushing the using all the using all the registers, then at a time all the registers will be full. Okay, so whatever so how will you do programming with all these registers and already occupied? Whenever data, whatever data you have in registers, you if you don't send it urgently, just push it to the stack whenever you want to get it. I have told it before also. Okay, you just put the data into the stack. Okay, if you don't need the data, okay, right now, then you just put into the stack, and whenever you need it, you just get it back. This is one way. Okay, now suppose your data is in BC pair. Suppose your data is in BC pair. Okay, simply you write what? Push B. You write push B. So what will happen if you write push B? When you write push B, you are simply pushing the contents of BC pair into the stack. This is your top of stack, right? Now when this goes, the data of B will go here, and the data of C will go here, right? Right or wrong? So I hope you remember the push and pop instructions. So once this is pushed into the stack, BC pair is now free because I have already stored the contents of BC pair in the stack. Okay, this is the top of the stack, and these are the others memory location. So I have pushed the contents of B and C into the stack. Okay, so now B and C are free. Okay, the way you can use it for anything. Now cleaning the way. So what do you want? Your original value is secured in the stack. Whenever you want the data, okay, so change the value, so you can now change the value of BC pair. Okay, or you can use it for anything. Okay, because our BC pair is free. So what you so your original value is secure in the stack, right? So whenever you want the data back, this data is stored in the stack. Whenever you want the data back into BC pair, what you have to do? You have to do you have to use a pop instruction. You have to use a pop instruction, so you'll get the same data in the B register. Okay, so what I'm trying to say is, if you don't need the data in registers right now, go on pushing the data in the stack. Okay, go on pushing the data of the registers into the stack. Okay, whenever you need them, just get them back. Okay, just keep in mind, if you push 1 to 3, you will get back 3 to 1. So I think this is clear. See, I have used pop B. Okay, so what happens with pop B? The data of B which was stored in the stack is gone to the BC pair, and the contents of C will go to the C register. Okay, so push. So this is how that this is one use of stack to store data. If you don't need the data of registers right now, then you can push push the data in the stack, and whenever you want to retrieve, whenever you want to get back the data from the stack, you just do a pop. Okay, so this is one use of your stack to store data. Okay, now the third use is the second use is to store return address during call instruction. During call instruction. Okay, now do you remember call instruction, which is 18P6? Okay, so I'll just give you a recap. Okay, this is your program. Okay, this is your call instruction, and then your program comes to an end. Okay, so this is your main program. So you are calling a function. It will go to the function. Okay, it will execute the subroutine. Okay, and then it will return to the next instruction. Right. So this is your subroutine. To return from the subroutine, you need a return instruction. Now to invoke the subroutine, you write a call, right? Sub you to invoke you write a call. So program will come to will come up to here, that is up to call. The program is executing and the program has come up to here, that is call instruction. Now it will go to the subroutine. Okay, it will go to the because it is called sub. It will go to that subroutine. Okay, then what happens? And execute the subroutine. Okay, and execute the subroutine and come back to the next instruction of the main program. Right? You already know this. Now, so as to come back to the next instruction, the processor needs the address. Okay. So do you write a return with address? Do you write return with address? With address? No, we don't write any return address. Any address with the instruction return, because this is a subroutine. It can be called from anywhere in the program. So right, going to the program, microprocessor should store the address somewhere. Understood? I have told in the previous class also. So before going to the subroutine, the microprocessor will store the return address somewhere else. Where is the where the processor stores the address, return address? Microprocessor it stores the return address into the stack. So it will just push PC. It will just push PC. Okay, into the stack by into the stack. Okay, that means the return address will be stored at the top of the stack. Now PC will get the address of the subroutine. So P is so P yeah so PC is now free. So it will get the address of the subroutine. Okay, it will execute this subroutine. Okay, on return the address which was stored in the stack, that the which was stored in the stack. Okay, what will happen? It will it will execute the subroutine on return the return address which was stored in the stack will simply popped back. It will be popped back. Okay. It will return. It will pop PC. Okay. So whatever address was stored in the stack. Okay. Whatever address was stored in the stack, then this address using push, this address will while during return this address will be popped back from the stack and it will go to the next instruction to be executed. Okay, next instruction to be executed. Okay, so all of this I have explained very clearly in the previous lecture, I remember. So just go through it. Okay. So pop PC will get you back the return address. So all this I have made you clear in call instruction. So please watch the video before coming here. Also all this was a recap, was a simple recap. Now we will start something new. So why do we always use tag? Because of last in first out principle. Okay, I have explained this also. Right? During multiple subroutines. Okay, during multiple subroutines, you remember, during multiple subroutines there are number of there are number of calls and there are number of returns, right? And there are number of returns. So if you so if you write 1 2 3 1 2 3 4, you will get uh, 4 3 2 1. Okay, so something which cannot use so this is the second use of your stack to store the return address during call instruction. Okay, so I hope this is clear. This was just a recap. I explained the call instruction very nicely, I think, in the previous program. So just this was a recap. So just get it clear more and more, then it will help you during your exams. Okay. Now something which you cannot do without stack registers. Okay. The third use is to read and write the flags. Now you remember that F is not a general purpose. F is not a general purpose register. I want the value of C register into B register. What should I do? I want the value of C register into B register. Okay, so what shall I do? Move B comma C. Very simple. Now I want the value of F register into B register. I cannot write move C comma F, right? I cannot write this. I cannot write this instruction because there is no such instruction. So what to do? F is not directly accessible by the programmer. You already know. But what if for some reasons you want to copy the value of flag register into some other register? Sometimes you may need that I should get the value of F into some other register. Okay, so what to do? Now it is not directly possible. There is only one way of doing it. How? How? By using PSW. Remember, PSW, it is used only in push and pop instructions. I have already told you. So what if I told you push PSW, push PSW, okay, and pop B, push PSW and pop B. Okay, so what happens? Now let's see what happens. What is PSW? It is the combination. What is PSW? It is the combination of accumulator and the flag register. Here, now this will be pushed into the stack first. Okay, this is PSW, right? So if I write push PSW and pop B, what will happen? This the accumulator data will get stored here and the flag register data will get stored here. Okay, then what happened? Now I have written pop B. Next instruction is pop B. So what will happen? That means I am copying the data into BC pair, right? So B will get the value of A, right? So B will get the value of A. When I write pop B, B will get the value of A and C will get the value of F, right? If I write pop B, C will get the value of F. Now B getting the value of A, you can also do it by simply move B comma A. It is very simple. If I tell you that copy the data of accumulator into register B, you can simply write move B comma A. But if I tell you to copy the data of flag register into C, it is impossible. Okay. So there is no other way in 8085 by which you can read the flag register. Okay, this is your only option. If you ever want to get the value of flag register into a user register, you push PSW and then pop it into another register. Okay, the lower byte in the lower register pair will get the value of F like shown in the example. Okay, the lower byte in the lower register will get the value of F as shown in the example. Okay, the higher byte will get the higher byte will get stored in the higher byte register. I hope it is clear. So if I write for another example, let me show you. Push PSW, then pop P. Okay, so what will happen? Push PSW, This is A, this is F, this is your PSW, right? Now you have moved the data into stack. Okay, we have moved the data into stack. Now what I have written pop P pop T. So what will happen? This is D pair, this is E pair. So E will get the value of F and A will get A will get the value of D will get the value of A. So we are getting the data of flag register into register E. So this is the only way possible where you can read the flags. Okay, now I'll show you how to write the flags. Okay, how to write the flags. This is the example of how to read the flag. Now I will show you how to write the flags. Okay, now, now I'll tell you how to write in the flag register. Okay, now suppose I written push B and pop PSW. So what will happen with these instructions? Push B. First I'll push the value contents of B and C pair into the stack. Right? Then what? Now what will happen? Then I have written pop PSW. So the value of B will go to A and the value of C will go to the flag register. Okay. So if I so A will get the value of B, which is very simple. We can also write if we move A comma B. Okay, but B will get the value of C. But what will happen? F will get the value of C. There is no other way in 8085 by which you have done this. Okay, by the F is getting the value of C. So this is in 8085 there is no other way of doing this. This is the only method. Okay, where you can write the flag register. Fine. So you have now a brand new value of into flag register. So if you remember, flags are changed by the ALU after every operation. Now if I ask you put 25H into flag register, suppose I have asked you put 25H in the flag register. Okay, how will you do? How will you write? What will be the program? We have to write MVI C comma 25H. Okay, then what will you write? Push B and pop PSW and pop PSW. So this will be your instruction. So what I have done, I first written 25H data into register C. Okay. Then what I have done, I have push P in that 25H will come into the stack is BC. C I have initialized 25H, so this will come to the stack and the value of B will go to the stack. Okay, whatever is the value, it will go to the stack. Okay, then I have written pop PSW. So after pop PSW, what will happen? The value of A will go to register, the value of B will go to register A, which can be simply done by move A comma B, right? Which can be simply done by move A comma B. Then also the value of B will go to A. But here I am getting move F comma 25H. That is the flag register. The flag register will get a brand new value of 25H. So F will get a brand new F F F F will get the value of 25H. So this is only possible. So you understood how the flag register gets affected by the data 25H. So you are getting a brand new value of 25H. Understood? So this is how you can write the flag register. Okay, so you can read as well as write the flag register. So please tell me, did you understand? to read from the flag and write to the flag. So that I hope this is clear. So this was the third use. If you have any doubt, do ask me in the live sessions. Okay. Now the fourth use. The fourth use of stack is to pass parameters to pass parameters to subroutines. Okay, to pass parameters to subroutines. Now here I will leave this topic as of now. Okay, at the end I will explain this with an example, so that next I am going to teach you subroutines, because without learning subroutines clearly you cannot understand this point, this use. So then if you remember, if you understand the subroutines clearly, then only you can understand the value, the use of this use of this tag. Understood? So what is the meaning of passing parameters? So what is the process of passing parameters? I will show you now. Okay, then you can after you can learn about how to pass parameters to the subroutine. So now I will show you how to what is the meaning of passing parameters. Okay, so let's proceed. Now friends, tell me, what is a subroutine? The function. Okay, in a program, if there is any operation that needs to be operated again and again, like multiplication, 805, there is no mul instruction. You will not find any mul instruction in 805. Okay, so you have to write a loop where you go on adding the numbers multiple number of times, right? So you are multiplying a number in a part of the program, and then in some other part you are writing the same program. That is, in different portions of the program you want to do the same section. Okay, so what option is, write once, copy paste again, copy paste? That is not accepted. If you know you want to do it again and again, you can just create a function from where you have from wherever you want to do, you just call the function. Understood? It will find the multiplication program and then come back to the main program. Understood? So in short, if I tell you, instead of writing the multiplication program repeatedly, you just write a multiplication program separately as a function. Okay, and whenever you need that multiplication program, you just call the multiplication program from your main program. Okay, understood? So that is how the size of the program gets reduced. Okay, now subroutines are used because we can easily manipulate whenever necessary. Okay, so I will teach you how to pass parameters. Now, what is a parameter? You've written a function in C programming to find the factorial, right? Now this is your whole program. You have made a function by the name fact. Okay, as an example, you have made a function by the name fact. Okay, I think you have learned in C. As an example, you know how to write it. Now, suppose your function finds factorial of 10. Okay, whenever you call this function from your program, it will give you factorial of 10. So, are you going to find the factorial of 20, 30, 40? But understood? But what if you want to find the factorial of 10, 20, 30, 40? Are you going to write different functions for them? Okay, are you going to write? No, because the method for finding factorial is same for every number. So why I'll create different functions? Why not create a general function instead of finding the factorial of 10? It will find factorial of n. Yes, you have seen this. In bracket, if you write fact n, fact n, you are you are calling the function, then you write the body of the function, whereas whenever you did whenever you are calling the function, from where you write the factorial in the bracket, you write your parameter, let's say 10, 20, 30, etc. That is your parameter. So understood what is your what is a parameter? What is a parameter? Okay, a value passed by the main program to do the subroutine. If you write fact 10, if you write fact 10, okay, that 10 will go to the subroutine. It will find the factorial of 10 and then it will come back. If you write fact 20, if you write fact 20, it will find the factorial of 20 and will come back. Okay, so it will and will come. So how do you pass a parameter to the subroutine is what you are learning. Now to give the value to the main program, you need to store the value. So the first method of passing the parameter is using using registers. Okay, the first parameter. I hope you have understood what is parameter. Okay, now the how to pass parameter. There are methods. Okay, first method is using registers. Okay, okay. Now I will show you how to pass the parameters using registers. Okay, so this is your suppose this is your main program. We're executing it, and then we found this MVI 25 MVIB, 25H. Okay, now what is the value of the parameter and how I have passed it during what using what? Say what is the first line of the subroutine? Move A comma B. Okay, that means A is taking something from B register. Fine. So before calling the subroutine, okay, what I have done, I have put the value 25H into register B. Before calling the subroutine, I have put the value 25H into register B. So how the subroutine will find the function of the factorial of 25? That means the parameter 25H is passed to the subroutine using B register. Understood? The 25H is passed to the subroutine using B register because before calling I have put 25H into register B. So this call is when you write call subroutine, this 25H will come to register H. Understood? So please tell me, do you understand it? Please tell me, did you understand this? That means the parameter 25H is passed to the subroutine using B. Now in the same program, in some other part, I want to find the factorial of 35H. So what do I do? And what do I do? I have to change this number MVIB, 35H. Okay, and then you have to write again call. Okay, so you go to the same routine, but now you will find the factorial of 35H. Okay, you need not have to change the subroutine again. Only if you change the value, then only then the program will work. Okay, that means you are passing parameters using registers. So what is the method passing the parameters using registers? Now, if you want to find the say, simple interest, you need to pass three parameters. Suppose simple interest, that is P, N, and R. If you want to find the simple interest, you have to pass three parameters into the subroutine. Okay, let's take the three examples: NBIC, 05H, MVI B, 16H, and MVI D, 0AH. Fine. So I have initialized three registers with different values to find the simple interest. Okay, you will put these three parameters in three registers. You call the subroutine. After initialization, you call the subroutine. Okay, the subroutine will go on taking the parameters from the registers one by one, right? The subroutine will go on taking the register, taking the parameters from the registers one by one, and it will do the operation on that. So you can pass multiple parameters, but how many parameters you can pass? 2, 3. What if I want to pass the 10 parameters in a single call? If I want to find, if I want to send 10 parameters in a single call, okay, is this possible in HDFI? Never, because they are not 10 registers. So this really means that this method will fail when there are lots of parameters. So how many parameters you can pass using this method? We can't we can't pass 7 parameters because that will block all the registers. So how are you going to use these registers? So using this method, you can pass at the most one or two parameters. So this is the simplest method, but what is the limitation? You can pass only one or two parameters, not more than that, because you have only 7 registers. Understood? So this is the advantage which can be overcome by using memory. Okay, you have 64 kilobytes of memory because that's because I should pass parameters as I want. So what are the parameters? So what are the parameters? So pass your parameters using. So let us now learn how to pass the parameters using memory. So this method is simple because I will initialize the register B with 25H, then I have passed into the put this parameter into the subroutine. Okay, the subroutine executed, and then it has returned back to the next instruction. If I have put another data, then the same program will be executed and it will return to the main program. Okay, if you want to pass 3 parameters, you can also do that, but but I don't think but you can at the most you can pass one or two parameters because it has 7 registers, and if you block all the registers, how it will how it will help you, because in subroutine also you need some registers, right? So if you block all the registers in the main program, how will you use the other registers in the subroutine program? Okay, so you have to keep this in mind. So you cannot use all the registers in this method. Okay, maximum one or two, but this is the simple method. So this problem is overcome by using memory. You have 64 kilobytes of memory, so you can use as many memory locations as you want. Okay, so let us go to the next way of passing parameters using memory. Okay. Okay, now I'll show you how to pass the parameters using memory. Now every time we look at the first line of the subroutine, it will tell you the story that is going on. LDA 2000 means A is getting the value, stored in memory location 2000, right? Now, Now LDA is getting the data stored in memory location, whereas in the previous example, we have used registers. Register A is taking something from register B. So in the first example, you passed your parameter using register, but here in this example, you will pass your parameter using memory location. Now see, in example 2, your parameter is 25 each. Understood? You passed your parameter using memory location 2000 each. What you have done, first of all, you have put your value in 25 each into register A, and then you have put the value of accumulator in memory location 2000. Okay, so that A becomes free. Now You just store it in a and store it in a location 2000. Okay, store in location 2000. Now you see here you are not blocking any register. Once you store in register A, okay, it gets transferred to some other location and A gets free. Again, you can store some other detail store edited some other location. Okay, you can use any other data and you can store in some other location. Okay, now let me make you more clear. Let us start a program. MVI A comma 25H. Okay, then STA 2000H, then MVI A comma 45H, then STA 2000H. Okay, then MVI A comma 35H. Okay, then STA STA comma 45H. Then call subroutine. Okay, call subroutine. We'll go to the subroutine. Okay, here it is written LDA 2000H. Okay, then return. Now you see no 98 is the to the sub 98 to the subroutine. Remove the parameter, you do the operation, remain the parameter, you do the operation, and so on. Okay, so you pass these three parameters. You pass these three parameters. Which parameters? 25, 45, and 35. Okay, and as many parameters you want. Okay, now so that all that I am trying to say is that you can pass as many parameters as you want. You are not blocking any parameters. So advantages of this method, you can pass multiple parameters using this method. Understood? I hope it is clear. So advantage of this so advantage of this uh, instruction is sorry passing parameter is this is you can pass as many parameters as you want. You are not blocking any register. So advantage is you can pass multiple parameters using this method. But drawback is it is rigid. Why it is rigid? This is a subroutine. Okay, this is a subroutine. What does this method say? Pass in the parameter using using memory. This subroutine is taking parameter from memory location only 2000. Okay, is the taking the LDA, it is taking the value of 2000 into accumulator. Okay, it is using the value only 2000. Okay, that means for that means whoever wants to use this should keep 2000 available for passing the parameters. Understood? It should keep the memory location 2000 to pass the parameters. What else if you have already used 2000 for something in your program? Now you cannot use this subroutine because you have used 2000 for any other purpose in any other program. Okay, so this method is rigid because it only works on memory location 2000. Now you cannot use this for the subroutine dictates it will only work while memory location is 2000. Now this is contradictory. Whenever I say memory, it should use any memory. No, not only 2000, but you want to use memory in a more flexible way. So what is the more flexible way? Because it works on a fixed memory location. Okay, so now using memory, so we'll use now another so you we will use some more flexible method. I think you have understood this program. This method only was this parameter. The pass the this process will pass the parameters in memory location 2000 using only memory location 2000. If you're using memory location 2000, then only it pass the parameters. This is a drawback, but you can pass as many parameters as you want. But in first example, what we have done, we have used registers, and we can pass only one or two parameters because it works on registers, and they since there are seven registers. And since there are seven registers, so if you use all the registers, it will be blocked. Okay, you cannot use all the registers at the same time. I think it's clear. Okay. Now, what did I say? The key to understand is to find the line of the subroutine. Is to find the first line of the subroutine. In first example, subroutine takes the value from B register. In second example, subroutine takes the value from a fixed memory location. See, it takes the value from a fixed memory location. Okay. In the second in this example, subroutine takes the value from M. Okay. So what is the difference in second example 2000 is the memory location and M is the memory location. Difference is in the first case it works only on memory location 2000, but the second one works on memory location decided by the programmer. Understood? The second decided by the programmer. So if you change Alexa H 2000, there will be only difference because the subroutine will take now from 2000, unlike the second example, M can be any location pointed by HL pair. So you have control over subroutine while calling the subroutine. You as the caller. This is a function. I choose what is the parameter. I choose where to pass it from. My memory location 7000 is free. Alexa 7008. Now put the value any parameter is m. So whatever the parameter you put will be taken by the subroutine from memory location m. So this is a wonderful because you can pass parameter using memory location decided by you as calling. Okay, you can pass parameters like this. Understood? Let me. I think this is a bit of theory. So let me give an example. I think you have understood. In the second I'm repeating again. See, there this is you are passing parameters to a fixed memory location. Understood? In the first example, you have passed parameters using registers, but since all the registers can't be used, we are not using it. In the second example, we can pass as many parameters as we can, but it will work only on a dedicated memory location. But here, what is the third example? You can pass as many parameters as you want using M. Okay. So first of all, for using M, what you have to do? You have to initialize the HL pair. Okay. So the advantage is you can use as many. You can use any memory location for passing the parameters. So this is a short summary. Now let me show you by example LXI H comma 3008. Okay, then MVI MVI M comma 45H. Then INX H. Then MVI MVI M comma 35 H. Then INX H. Then MVI MVI M comma 45 H. So first is so here you see the first parameters is passed. Okay, so you pass 25, then HL becomes 3001. Okay, and then you pass the second parameter. Okay, then and then HLPR becomes 3002, and we pass the third parameter. So you passed 25, 35, and 45 using memory location 3000, 3001, and 3002. So you are uh, so you as a programmer, please go on passing as many parameters as you want. Please tell me, did you understand? Okay. But drawback is it blocks the HL player. It blocks the HL pair. In this example, you can pass it as many parameters as you want, in different locations by using M. But the drawback is it blocks the HL pair. Okay. Now see, in first example, in order to pass one parameter, you blocked one register, two parameters, two registers, now three parameters, three registers. But here no matter how many but here in the example, no matter how many parameters you are passing, you are blocking only two registers. Without we can pass a number of programs in a flexible way. We can do our program in a flexible way, right? So last and the final one, passing parameters using uh, which are so the last one, the other final one missing a passing parameters using stack, which is skipped. Remember, use of stack passing parameters. So I hope you understood how to pass parameters using registers, using memory location, fixed memory location, using M. Now the last one is how to pass parameters. How to pass parameters using stack, which we skipped. Okay, now just now before we go there, let's understand the sample program. The question is, what is the value of A after the program is over? This is a typical exam which give question exams. They will save you a program, and they tell you a program, and they tell you to tell what is the value of the register of so and so program. Okay, now let us see the program. MVI A comma 48, then ADI 58, then LXI H comma 2008, then INR A, then call subroutine, and then call. Now call subroutine. You should go to subroutine. It will first written pop H, then PCHL, then MVI A comma 55H, and then return. Okay. So after this program, the examiner may ask value of what is the value of A here. Okay. Now call subroutine pop H. Pop H. What does it mean? it pops the data from the top of the stack to HL pair, right? It pops the data. What does pop H means? It pops the data. It pops the data from stack into HL pair, right? HL pair. But we have not pushed anything, right? So what has happened here? Without pushing, let's pop the data. There is how now you remember uh, whenever we do a call, there is a push. The address of the next instruction, which was there in the PC, a call does a push PC. Remember, when you are doing call, it will push the PC so that the program can return to the next instruction. So that means the return address was stored in stack, of course in two locations. So first line of the subroutine is a disaster. This is a disaster, okay? Because you have popped out the return address in HL pair. So the return address is now no longer no longer in HL pair, right? Then it is no longer in HL pair. So the so the return address it is in so the sorry so the return address it pops the data from stack into HL pair, right? Now you it now so the port is not longer in HL pair. It is in now you write PCHL. Okay, what does PCHL means? Such a cute little instruction, but it is harmless. But it is not. You think it is harmless, but it is not. PCHL gets the value of HL pair. Okay, now HL address has the return address, which means PC gets the. What does PCHL means? After pop page, what it has done? It pops the data from stack into HL pair. Then you written PCHL. What does PCHL done? PCHL will do PC gets the value of HL. Now HL address has the it HL address has gets the value of HL pair. Now HL address has the return address, which means PC gets the return address. Understood? PCHL now the PC will have the return address, right? Have the return address. PC get that means it will directly come to halt and MVI A,55H and return will never be executed. Once the return address has come to PC, so it will go back to the next instruction and this program and these instructions MVI A,55H will never be executed. Understood? Because the PC has already got the got the return address by pop page. Understood? Because pop page it has retrieved the return address from the stack into the HL pair, and then we write PCHL, that is the PC gets the data of HL pair, which is nothing but the return address. So it directly it takes the return address and returns to the next instruction of the main program. I hope this is clear. And so MVI and so let us go to the MVI A for and please tell me, did you understand? Now what is the last value of A? So so answer now see here MVI A comma MVI A comma and suppose 98. Okay, then then sorry 48. Then 40 plus 50 it is 90, which is stored in later. Then Alexa is 2000H. HL pair is loaded with 2000H. INR A A is now 91 each, which is already in the accumulator. Then we have called A, then we have called subroutine. So pop each, it has popped the HLPR address from the stack, okay, and PCHL HLPC will give the return address of HL, and then it will turn back to the next instruction. So and these two instructions, MBA, conflict behavior and return, these are not executed at all. So it will come to the next instruction, and hence the value of A is 91 each. So these are tricky questions that can be asked during the GATE exam. Clear? So I hope this is clear. This is clear. Okay. Then we will go to the, so basically PCHL. What does it? What is done? PC gets the value of HL. PC gets the value of HL. Okay. Now HL has the return address, which means PC gets the return address, right? Yeah, PC, how that is pop H. We have written pop H. So the return address has transferred to HL pair. Now again you have written PC HL. So PC gets the value of HL pair. So now PC contains the return address, right? That is, it gives the address of the next instruction to be executed. That that means the program will take a shortcut and directly come and directly come. These two lines will not be executed, and these two lines, that is MVI A comma 55H and return, these instructions will not be executed. When the PC will get the return address, it will come to the next instruction of the main program, right? So basically the value of A is 91. So these are the typical questions that can be asked during your gate exams. In normal exam, they will not get such program. So if you are aspiring for gate, they have to learn what actually is happening in the program. Okay, I hope this is clear. Okay. Now, what have you learned from the, for example, never use pop, never use pop in the beginning of the subroutine. The moment you have used pop, you have removed the you have removed the return address from the stack. Suppose you have removed the return address uh, from the stack. Forget about the PCHL. Suppose you have removed the return address from the stack. A would be 55. Understood? If you have PCHL is the savior in the program, PCHL is the savior because PC is the value of HL. That's why you can return to the main program. But if PCHL was not there, only you have written pop a, only you have written only you have written pop age. So the value of A would be the 55 age, and it and what the return will do, it takes the return address from the stack. Now there is no return, it will, because there is no return address in the stack, because after you write pop hl after you write pop h, the return address has gone to hl pair. Okay, so after when you write return, it will pop the return address from the stack, but there is no return address in the stack because it is already retrieved in the HL pair. Understood? So basically, this PCHL was there to save the program. Okay, otherwise you have got the value 58h, 55h. Okay, you understood? Now I teach you passing the parameters using stack. Okay, passing the parameters you stack, which we skipped. Now this is your main program. Okay, you have written LXI, you have written LXI P comma 2008. Okay, now this 2008 is the parameter that I want to pass. Okay, this is the parameter which I want to pass. Fine. Now then I written push B. Okay, when this push B, you have push BC pair, which means you have push 2000, right? You have BC pair, you have push BC pair, that means you have push 2000 where in the stack, right? Right? Now let's see LXI P comma 2008, then push B, okay, then call subroutine and then halt. Okay, since you call the subroutine, let us with the subroutine pop H. Okay, then return. When you when you go to the subroutine, okay, now this is an example. When you get to the subroutine, you want to get the parameter back. That is 2000. So you used pop H. So what are you going to do? What are you going to you have done pop H, right? So what are you going to get? Do you get the parameter? No. I have already told when you push the parameter, there is another push during call, right? When you push the parameter, there is another push during call. It is used by the microprocessor. Now the microprocessor will push the return address, understood, to the stack. Then microprocessor will push the return address into the stack. Understood? Now when you enter the subroutine, you are interested in getting the parameter, right? But above the parameter, the return address has been stored. But above the return address has been stored. See the higher byte and the lower byte. Now, so to access the parameter, you get the return address and then access the parameter. So first pop page. So the return address has been the return address to the it has got the return it pushed the return address into HL pair. After you write pop page, the return address has gone to HL pair, right? After you write pop page. Okay. Now the You and now so to the address has been stored. So to access the parameter, you get the return address and then access the parameter. You first pop H, get the return address into HL pair. Now you do pop or anything, get the parameter into register. You do pop B or anything, get the parameter into register. Okay, in this get the in parameter into register. You do pop B or anything, get the parameter in you do pop B or anything into get the parameter in register. You do 100 you do return address in your BC pair, right? You do return address into BC pair. Now neither is your parameter nor your return address is in the stack. Understood? So to come back, use the option PCHL. PCHL will get the return address from the pair. Okay? PCHL will get the return address from the pair. And and hold the hold the program. So now now you understood by skipping by skipped because you why you have skipped that previous chapter because you have to know how to pass the parameter into the step. So hope you understood the class very well. Enjoy the learning and hope you enjoy and have a nice day. But let me tell you this program again. When you go to the subroutine, when you go to the subroutine, okay, you want to get the parameter back in 2000. So you used pop h, right? Pop h. What are you going to get? Do you get the parameter? No. I have already told when you push the parameter, when you push the parameter, there is another push during call. It is used by the microprocessor, right? Microprocessor will push the return address to the stack. Fine, push the return address into the stack. That is, return address will come above the stack. See, return address has come above the stack. Have you seen? So to access the so to access the path above the parameter, the return address has been stored. So to access the parameter, address has been stored. So so to access the parameter, you get the return address and then access the parameter. So first pop page, okay. What you will do by pop page? Get the return address to the HL pair. Get the return address after pop page. Get the return address to the HL pair. Get the return address to the HL pair. Okay. Now you so first pop page. Get the return address to the HL pair. So now you get the return address and to HL pair. Now you do pop B or anything. Get the parameter into register. Okay, get the parameter into register at the into register BC. Now neither is your parameter nor your return address is in the stack, right? Because the return address is stored in the HL pair and the return address is not in the stack. Okay, to come back, use the option PCHL. You have to come back by by using the PCHL. Okay, by pushing the PCHL. Okay, PC will get the return address from the HL pair. Understood? PC will give if you write PCHL just like other example, PC will get the value from HL pair and then you can return to the main program. Understood? Okay. So it will come to the main program of the main of the next instruction of the main program and the program will come to halt. I think it is clear to you. So this is the end of today's learning. Hope you enjoyed the learning. If you have any doubt or queries, to ask me in the class sessions. Okay, and thank you and have a good day. Bye.